Hello everyone. Today we're going to have a very special video. We're going to unite my models with Einstein's field equations. And I'm very excited about this. I've been wanting to make this video for some time. And the way we're going to do this is I'm going to go back and I'm going to re-explain my model. And then I'm going to show you Einstein's field equations and interpret it according to my model. And the fact that it works out perfectly should tell you something about how I'm modeling these things. So we're going to do a quick rerun just so everyone knows exactly what I'm saying here. Euclidean geometry, Euclidean space, 3 dimensions. Inside that you have 1 cubic space. If you double it and give each dimension a vector, you end up with 6-dimensional vectors from a core like this. And in order to fully surround all 6-dimensional vectors, it requires 8 cubic spaces, as you see here. And if you have 8 cubic spaces, then between those spaces you have 3 transitional planes. And if you have a particle going down on the page, right, then it creates a force out, charge in system in front of the particle, and it creates then a force in, charge out behind the particle. And this is a duality, which gives you a plane of density. And that plane of density has this duality, has quad outputs, and those quad outputs are charge, negative and positive, and polarity, monopole and dipole. And so you end up with density, charge, and polarity defined naturally, very simply, intuitively. And this plane of density would come out across the plane like the surface of water. And on that plane, you would get what de Broglie and Bohm call standing pilot waves. And those standing pilot waves would create this surface you see here and would accelerate and decelerate particles as they pass through it. Now, this would be a Planck core. These are meant to define how force out, charge in below the particle, below this Planck core, and charge in, force in, charge out above that Planck core. And we're going to jump ahead now, and we're going to go straight into Einstein's field equations. And I've written them here. My theory of mass is FV, FD, FC. And what that really stands for is the total force of velocity applied to any particle by the system it's in. So what that would mean is we're on Earth. Earth is moving in the galaxy or around the sun is moving in the galaxy is moving in the universe, and all of that energy is applied to us because we're on Earth. So we're born on Earth, we're born into a system where that velocity already exists, and this is the force of velocity given to any particle by the system it's in. Very simple. FD is the total force of displacement. Everything has a size, and that size is relative to the particles around it. And therefore, you have a force of displacement based on your physical size by everything around you. And every particle has that. And then FC, this is the force of charge. And this actually comes out to be charge and or mass. So E equals mc squared is all within FC because this is the total force of charge. And the way that works for me, the way I explain it, is that an antipole, right, with this quasi-particle inside, inverts and becomes a charged dipole with this quasi-particle on the outside. And so that is mass and charge, right? So the mass of any particle is an inverted antipole, and it's inherent in the atmosphere, which is why it solves quantum gravity and regular gravity. as long as you understand that regular gravity is not a universal force. It's a local force from the core of a field outward. And it's part of this Fc. So E equals mc squared is relative mass and charge based around the displacement of a particle that's already accelerated to the system. And so Fc is relative velocity to the velocity of the system that you're already in. And that's it. That's how you calculate charge and mass in my model. Now, let's jump to Einstein. R is the Ricci curve, right? Minus 1/2 R, the scalar, by G uv mu nu equals 8 pi gt mu nu. Now, this is where it becomes interesting. For me, 8 pi becomes these orbital additional dimensional vectors around a core. So this would be a charged dipole. Right? If you were looking at, say, Earth, these would be, right, the trade winds and the polar vortices around the particle itself. And this would then be these two smaller ones squished into it. And two of these combined would create a torus. And this is what you're looking at here. So these create a torus on top and a torus on bottom. And this is how a galaxy forms. And the core of a galaxy is a magnetic monopole. And I know they're not supposed to exist, but this is how it works. When Einstein created his field equations, he quite literally transferred distance to time. And that's fine, as long as time is constant. And it is as a measurement until you make it relative, right? So you can accelerate and decelerate. And to me, in my model, Einstein's relative time is acceleration and deceleration. And so the way that that works is very simple. Imagine Schwarzschild solving Einstein's field equations. And when he did, what did they do? They got to the point where in the solution you had unlimited mass in a point, which is an infinity, which supposedly couldn't exist, but now we found them in black holes, so they say they do exist. Here's the thing. It doesn't show the reversal, okay, of what happens. So there is a reversal, the particle going down on the page, charge in, force out below it, force out in, charge out above it. And this reversal of force and charge is hidden in Einstein's field equation. So if the mass of a particle is due to the antipole inverting, putting this quasi-particle around it on the outside, like our planet, Mars, Venus. If you invert the antipole, then the force in, charge out system is gravity, and you would have an additional charge, a dipole charge, but the charge is very, very small. So if you think of an electron as having charge but almost no mass, a charged dipole like a planet or a proton would have mass and almost no charge. They reverse. And the same thing happens between a star and a black hole. And the black hole is simply a reversal. So instead of acceleration, which is what happens when you get a positive charge, like a charged monopole, a star, that's an acceleration. And when it decelerates slightly, but is still in an accelerated, it's still faster than the system it's in, but it's decelerating, then the polarity flips, which is why our star flips every 11 years. Its polarity. When the entire FC goes below, becomes a negative of the FV, then the forces reverse. And they go from force in, charge out, like a star, to force out, charge in, like a black hole. Okay? And this is at the core of a galaxy. Why? Well, there is in my model, this reversal that happens from acceleration and deceleration, which then explains antiparticles, quantum tunneling, and now I'm using it to correct the model around Einstein's field equations when stars become black holes. And they become dark stars. Well, what happens is, if what I'm saying is right, if my model is correct, then the atmosphere around chemtron structure, dark matter with no gravitational force, right? The mass of particles is due to this antipole inverted, becoming an atmosphere, giving it mass. And so, at the core of a black hole, or at the edge of it, when the forces reverse and charge goes in and force then goes out, what is occurring is that the atmosphere of the chemtron structure, the dark matter, is being stripped off of it, taking its mass and reducing it to zero. And those small particles that made up the inverted antipole that gave it mass then go to the core of the black hole, and only the energy with no mass goes into the core. And what's left is chemtron, dark matter, with no gravitational force, that gets pushed out, and you can see it orbits this way and orbits this way. This is a toroidal vortex. This is the shape of the galaxy. These are dark matter flows with no gravitational force. I call them chemtron structure. Chemtron structure is being forced out and then rotated back in between. Okay? This is the acceleration and deceleration of particles. This is the dimensional vectors that then create this shape, but it's reversed to the star. Well, how would that work? It's pretty simple. I've said that the field created around particles in motion, a single unitary particle creates a binary output, which is the plane of density, and that on that plane of density, right? So if a particle's going down here, this core creates a force out, charge in system, and behind it you get then the big particles moving back in, so force in and charge out, and that's the difference that creates the quad outputs, okay? Defined by Dirac's equation, and those are, as defined earlier, charge, negative, and positive on two sides, and monopole and dipole on the other two. Right? So this is charge, this is polarity, and this, I've also said, is interpreted using Cantor's ternary set, which is quad outputs in thirds. And so this would be no thirds, 1/3, 2/3, and 3/3, and this would be one or the other, neither, and both. Well, how would that apply to what we're talking about here? Well, from this core moving outward, right, like this, you would have a helical path, right, because these outputs create de Broglie or Bohm standing pilot waves. And to go over the first one and then under the second one would create a helix. Okay? And a helix is simply a circle with a line through it. That's pi. And if you separate the ends of that circle, it becomes a helix. And the length from here to here is an arrow of time moving outward. So the deterioration of structure, right, is set, the cadence of time, by the size of the particle and the constant of pi, the deterioration of that structure. And if that's true, then when you take it apart, then the helix that is formed moving outward, the arrow of time comes out of the center. And this is above, below, and then back up again. So this becomes your helical path right here. And for instance, in this one, it would go, each one of these is made by 2 de Broglie or Bohm standing pilot waves. So each one of these becomes an accelerated torus, right? That you can see. And the core of those are accelerated one way or the other. So how does this output? Well, the output is Maxwell's equations, and there are 4 of Maxwell's equations, and they are charge monopole, magnetic monopole, charge dipole, and magnetic dipole. So what happens as this field, right, reverses, you switch negative and positive charge, or monopole and dipole. This is how we define antiparticles. This is how we define quantum tunneling. And if this same thing occurs, right, in his field equations, the Schwarzschild solution to these would not put all that mass in the core. It would reverse from a charge monopole to a magnetic monopole, which means it would go from a force in, charge out system like a star to a charge in, force out system of a magnetic monopole. And if that's the case, then you wouldn't get all that mass, the charge, right? The inverted antipole that creates the mass around dark matter would be stripped off of the dark matter, and what you would be left with is what would be considered a dark star. This would be a dark star that radiates dark matter in this shape, right? And this is a galaxy. This is how it forms. The field equations mathematics are correct. I'm not arguing with them. I'm saying that if you use Dirac's equation as interpreted by Cantor's ternary set on top of, right, the plane of density as defined by the Lagrangian and the Hamiltonian, and the output of those become Maxwell's equations, 4 possible particles, that you're switching from a force out charge in system like a star to a charge in force out system of a magnetic monopole, which is at the core of this black hole. And when that occurs, the mass or charge, which is the same thing, remember, E equals mc squared of the Fc in my mass equation, is stripped from the dark matter and goes into the core. But the displacement, the actual size of the dark matter chemtron structure without gravitational force becomes a rotating current of these particles that then create the shape of the galaxy that we see. And I actually I came up with my model in 2004, and I've been building it ever since. I ended up writing the book. I'm now making these videos. And I just came across a paper that is from Igor Nikitin. I don't know how to say his name. I've only read it. But the title of the paper is On Dark Stars, Planck Cores, and the Nature of Dark Matter. And what he's saying is my model. It is dark matter orbiting, rotating outward from a core, a dark star, which must be a magnetic monopole. The difference is I'm telling you how gravity on the quantum scale works, and it's the same as gravity on our, macroverse scale, but that it's not a universal force. And if you can accept that, and it's right, and it seems to be, then what would happen at this core is that the displacement, the size of the chemtron structure, would simply be displaced outward under force. Right? And the charge that gives it its mass, or relative charge, would be pulled to the core. And this all happens because the FV, it has gone from positive FV, right? In other words, a positive FV is the total force of velocity given to you by the system. And if you're going faster than that, you have a positive FV. And if you go slower than that, you have a negative FV. So the positive FV becomes a negative FV, which forces the displacement, the chemtron structure, outward, and the charge, which gives it mass and its relative charge, into the core, then creates this model perfectly. This is how you align Einstein's field equations to my models. And again, before anyone starts screaming, I am not changing the math. I am changing the model and saying that there's a reversal, which is easy to explain. I just did. And that's why you have this controversy about unlimited mass in a single point, and that's not possible, and all the things that come from that. It's not necessary. All you have to do is reverse the force and charge. So how does this one, the other, neither, or both appear? A star is this. Okay? It is both. It has charge and it has gravity. A magnetic monopole has neither charge nor gravity. And one of these has gravity and the other one has charge. So if you were to look at our solar system, you would say a magnetic monopole would have neither. That would be our moon or the moons of the inner solar system. Charged dipole would be 1/3, and that would be gravity with almost no charge. And 2/3 would be charge with almost no gravity. And in my model, the outer planets are negatively charged, but have an anti-gravity atmosphere. And 3 would be both. And in the both model, you would have a star. You have both gravity and charge. And the way that works is in the orbitals. You can see it in the orbitals. What do I mean by that? Well, a monopole, internal moons of the inner solar system, have no other moons. They can't have orbitals. Right? Charge dipoles, like planets of the inner solar system or moons of the outer solar system, can have orbitals, but only magnetic monopoles, because it's a quasi-particle that forms from the inverted antipole. So the moons of outer moons or inner planets have this quasi-particle flip to the outside when the antipole inverts, giving charge and mass to those objects. The outer planets, negatively charged objects that are like Jupiter birthing moons. The red spot on Jupiter is a moon that's going to eventually leave. It's not just a storm. There's a particle at the core of it, and it is a moon. It's a charged dipole in the core of the red spot, and it will birth. Right? This can have charged dipoles, but those charged dipoles, because they're inverted antipoles, this quasi-particle flips to the outside. So outer moons can have moons. And those moons will be magnetic dipoles. Magnetic monopoles. And so 3/3, both, that's the star. It can have both charge dipole orbitals and negatively charged magnetic dipoles or magnetic monopoles orbiting it. So this is the orbitals and the forces. Right? The star has gravity and charge. The outer planets have charge but no gravity. The inner planets have gravity but almost no charge. And the moons, the magnetic monopoles, have neither charge or gravity. And that's it. That's how you define all of the particles in the system as Maxwell's equations, which represent particles. It all comes from charge in, force out, a unitary system creating a binary output. That binary output has quad outputs, which are charge and polarity, creating the three transitional planes, which then lead to Maxwell's equations. And that is proof, when you look at this, that Einstein's field equations, right, reverse. So when Schwarzschild came to the conclusion that negative, right, these are matrices of matrices, and there are 4 here, and there are now 4. We don't need these, right? So there are 16, and this first one is positive, and it's for the time, and this second one right here becomes negative. And that negative one is why we have this controversy about black holes and unlimited mass and a single point. And if you simply, at this point, because of this time, is acceleration and deceleration. If you go from an accelerated FV, force of the entire system, transferred to the particle that it's in, if this is positive, it's in an accelerated state, and if this is negative, it's in a decelerated state. And the difference between a star and a black hole is a star is accelerated and a black hole is decelerated. A star is a force in, charge out system, and a black hole, the core of it, is a magnetic monopole with a charge in, force out system. And that's it. That's 100% how you interpret Schwarzschild's conclusions, his solving of Einstein's field equations without infinities, so that it makes perfect sense.